In this data structure class, we will see the quick sort from third unit searching and sorting. And today's class, we will see the divide and conquer algorithm because the quick sort adopt the divide and conquer methodology for its sorting technique. And then we will see the definition of quick sort. After that, the algorithm for this quick sort. Then we will see some of the examples, and finally we will see the advantage and disadvantages of quick sort. Before merge sort, we will see the divide and conquer. It is an algorithm which recursively breaks down the very big problem into two or more subproblems of the same or related type. Okay, the division will continue until it become very simple. That is, the problem will be very simple to solve directly. Okay, that means the problem, that is very big problem of size n, will be divided into 2, that is n by 2, and this will be divided into n by 4, etc. Okay, and this will be divided into n by 4, etc. Okay, so the division will continue from top to bottom, top down, until the problem will be easy enough to solve. Okay, or otherwise it cannot divide further until the division will be continued. So the division breakdown is top down approach. See, once we divide all the problems and then it recursively solve the subproblem. Okay, the more number of small problems will be solved individually, and the solutions will be combined. The solutions will be combined. So this is called as conquer. Okay, to the subproblems. That is, the solution will be combined. These two solutions will be combined, and these will be combined. Okay, likewise. See, this is the solution for subproblem 1. This is the solution for subproblem 2. And then these solutions will be combined, and finally we will get the solution for the original problem. Okay, so the conquer is bottom up approach. That is, all small problem solutions will be combined together to form a solution of the huge problem, right? So this is bottom up approach. So divide and conquer is first divide the problem into small subproblems, and then the small subproblems will be solved individually and the solutions will be combined together, and finally we will get the very big solution, which is the problem of the very big complicated problem, right? Quicksort. Quicksort is one of the best algorithm when compared to our previous algorithms like bubble sort, insertion sort, selection sort, and merge sort, and it adopts the technique of divide and conquer algorithm. Okay, how the quicksort algorithm is working? See, first step, it select the pivot element. Okay, from the unsorted array, it will select any random value as a pivot value. Okay, this is the first step. And second type, sort the values larger than pivot to one side and smaller to pivot on the other side. Okay, see, from the left hand side, all the elements are smaller than pivot, and in the right hand side, all the elements are greater than pivot. Hence, now the pivot will get its right position. Okay, and step 3 is repeat step 1 and step 2 on both left hand side arrays and right hand side arrays. See, in the left hand side array, again we have to select one pivot element, and again the process will be repeated. Okay, and in the right hand side also we need to select any of the pivot element, and again the process will be repeated. Okay, and finally we will get one single sorted array. Okay, so this is the quicksort algorithm. Now let us see one example for this quicksort algorithm. The given data values are 40, 20, 10, 80, 60, 50, 7, 30, and 100. Now we need to sort these values by using quicksort. Initially, first we need to pick the pivot element. Here we will select the leftmost item as a pivot element. Okay, and there are number of ways to select the pivot element. but here we will select the first element as our pivot element. After selecting the pivot, next we need to partitioning the array. Okay, the partition elements of the array such that the resulting array consists of. That is, after selecting pivot, we have to get two different arrays. Okay, the first one, the subarray that contains the elements greater than pivot. Okay, the subarray which contains element greater than pivot will be moved in this place, and the data which contains smaller than pivot will be moved in this side. This side. Okay, and the subarrays are again sorted the original data array. Okay, and that is, the quick sort will be implemented in left side array as well as the right side array separately. Again, it will select one pivot and the data will be moved left side and right side. So at every phase, the pivot element will be placed in its right position. Now let us see how the partition will be taken place. Okay, our pivot is located in index 0. Okay, and totally we have 9 data items. 9 data items. Partitioning is, that is, pivot element is at 0th index. Okay, now we need to move the data item which are smaller than pivot into one side and greater than pivot into another side. Okay, for this we need two index. The first one is left index and second one is right index. Okay, left index will be incremented one by one from left to right, and right index will be decremented one by one from right to left. Okay, so the process will be repeated until left greater than right, left greater than right. Okay, so the first step is, while data of left less than or equal to data of pivot left plus plus. Okay, here we have two indexes left and right. Okay, these two indexes are used to verify the value with the pivot value. If the left value is greater than pivot, and this should be moved to right side, and if right value is less than pivot, then that will be moved to left side. Okay, so initially the left index is 20, the pivot index is 40, but this is less than or equal to pivot, hence left will be incremented. So left side will be incremented. So now the left index will get incremented, that is left equal to left plus 1. Okay, now we need to check the value. So the left index value is 10 and pivot index value is 40. Hence, left will get incremented again. Okay. Now left got incremented here. The value of left index is 80. The pivot index is 40. Okay. Hence, the left will stop here, and we have to check the data of right is greater than data of pivot. So the data of right is 100, the pivot value is 40. Okay. Now the right index value is greater than pivot element, hence right will be decremented. Okay. So the right index got decremented to 7, right? Now we need to check whether the data of right and data of pivot. Now the data of right is smaller than pivot value. Okay. See, the data of right is smaller than data of pivot. Hence, we need to exchange these two values. The data will be exchanged now. Okay. See, these two are moved. Swap the data left and data right. See, the data left and right got exchanged. Okay. And now left will get incremented. See, while right is greater than left, go to 1. So here right is not greater than to 1. The right value is 7, right? Again the process will be repeated. Okay. The left value is smaller than 40, hence left will get incremented. Left will get incremented now, right? Now the value of 60 is greater than 40. The value of 60 is greater than 40. Hence we will move to right index. Okay. Right index is greater than 40. Hence the right will be moved here. And now we need to check the right index value. The right index value is 80 and the pivot value is 40. Okay. So the right value is higher than pivot value. Hence right equal to right minus 1. See, now the right index is decremented. Now we need to check whether the right value is greater than pivot or not. Now the right is smaller than pivot, right? The right value is smaller than pivot and left value is greater than pivot. Left value is greater than pivot. Then what we have to do? We need to swap these two items. Now this is greater and this is smaller. Now we need to exchange these two values. See, these two values got exchanged now, right? And now while right is greater than left, then go to 1. The step will be repeated again. Okay. Now we need to check whether left is, that is the data of left is smaller than 40 or not. If the data is smaller, then left will be incremented. Okay. See, the left will get incremented now. So the left index is incremented. Now the left index is 5, right? And what is the right value? Right value is 60. Okay. 60 is greater than pivot value. 60 is greater than pivot value. Hence, right will be decremented. See, the right value is decremented. Okay. Now, left equal to right. Okay. If the left is less than right, then we need to swap the data. Okay. Now, right value is decremented because the value is greater than 40, right? Right value is greater than 40, hence right will get decremented. Now what happened? The left index is greater than right index. Left index is greater than right index. Hence, okay, swap the data right and the pivot. Okay, see, the right data is here and pivot is here. These two will get exchanged. Okay, see the pivot index that will be placed in fourth index. Hence, the pivot is placed in its right position. Because the data values from left side are smaller than pivot and data values right side are greater than pivot. Okay, see the data pivot left side are smaller and right side are greater. Okay, now we need to apply the quick sort in this left side array and the right side array also. Okay, and this is the algorithm for quick sort. Okay, the quick sort function which accepts three parameters. First one is array of unsorted data item, and this is the starting index and this is the end index. If start is less than end, then it will proceed further. That is, P index means pivot index. Pivot index equal to partition of A comma start comma end. Okay. A is nothing but the array. A is array. Okay. And we need to apply quicksort on the left hand of pivot index, and the same quicksort will be applied to right hand side of pivot index. Okay. And when the start is greater than end, then the loop will get exited. Now let us see the advantages of quicksort. It works rapidly and effectively. So the name is quicksort. Then it will do very fast when compared to our previous algorithm, but this is not the best one. Okay, it has the best time complexity when compared to other sorting algorithms like insertion sort, selection sort, merge sort, okay, and bubble sort. And quicksort has space complexity of n log n. That is, it cannot consume that much space. Space complexity is very less, making it an excellent choice for the situations when space is limited. Okay. See, if we don't have that much space, then immediately we can select the quicksort. And next, let us see the disadvantages of quicksort. This sorting technique is unstable because there is no proper key value pass initially. This is the first one. And it is not effective when pivot element is the largest value or smallest value. Or if more number of keys like pivot, then the sorting technique will be very ineffective. Okay, for example, if the pivot element is smallest one, then we need to move all the data item to right side of pivot. If the pivot is greater, then we need to move all the data item to left side of pivot, right? Hence, this is an ineffective one. And the performance of quicksort is reduced in the worst case scenario. Suppose if the array is reversely sorted, okay, if the array is reversely sorted, if we apply quicksort, then the performance will get reduced very much. Okay, so far we have seen the quicksort algorithm from third unit, searching and sorting. Here first we have seen the divide and conquer, because the quicksort uses only the divide and conquer for sorting the unsorted data items. And then we have seen the quicksort definition, and after that the algorithm and the example for this quicksort. And finally we saw the advantages and disadvantages of quicksort technique. And the next class we will see the heap sort. Thank you.